Hello everyone. Welcome to our show Non-Fictitious Science. Here we will tell you a real story about a scientific marvel and then we will discuss about the scientific principles behind it. And the topic for the day is the Silent Service-Submarine.
War in sea and air was more important in World War since the center power and the light powers were separated by vast sea and ocean. One important weapon at that time, the threat posed by the tiny demons, can be judged by devastation caused by them. British lost 5,000 ships due to the attack by the enemy submarines. At that time, only a few methods were available to detect these underwater demons, and that too were not so effective. Well, we will discuss it in detail after the story. So, first of all, let us start the story.
At the time of the Second World War, Hitler had built two of the largest warships, Bismarck and Tirpitz. Tirpitz was slightly larger and more powerful than her sister ship Bismarck. Bismarck was launched first, and planning was done to take it to Brest in German occupied France so that it can blow off all the supply ships for the Royal Navy. Bismarck was sent with a cruiser, Prince Eugen. On their way to Brest, they fought with 11 English battleships and cruiser, and finally they sank without ever reaching Brest. In the fight, the greatest English battleship, the Mighty Hood, and two to three other warships also met their fate. All the other English warships suffered huge damage because of the attacks by Bismarck.
After the Tirpitz was launched, the Royal Navy came to know that it is anchored in a harbour in Norway. They knew that if this ship came out, the Navy won't be able to stop her, since she was more powerful than her sister ships.
To attack on mighty Trippies and other two ships, Schornhorn and Lutzow. Operation Source was planned. The concept for the attack was developed by Commander Conway Verley with support of Max Horton, Flag Officer Submarine, and Prime Minister Winston Churchill. The Silent Demon X-class submarine came into play.
There were several naval mines beneath the water surface near the area where these ships were harbored. If the submarines touched them, they would explode and it would be its end. Luckily, they saved themselves from these naval mines. Total 6 midget submarines were used: X5, X6, X7 for Rapids, X8 for Lutzow, and X9, X10 for Scharnhorst.
Mission for other two ships wasn't successful. X-52 was sunk by direct hit of Tirpitz. X6 and X7 managed to drop their charges under Tirpitz but were unable to escape as they were observed and attacked. Both were abandoned and 6 crewmen were captured. Upon capture, the crewmen informed the German captain, Hans Meyer, that there would be explosions under Tirpitz within an hour. Meyer quickly attempted to move the ship away from the charges but was unable to do so before the charges exploded. Tirpitz was heavily damaged. While not in danger of sinking, she took over 1,400 tons of water and suffered significant mechanical damage. This attack was a major setback for German Navy as they lost the most powerful ship.
The damage was so severe that it took around 4 years for the repair. In a short while after repair, Oro Lancaster bombers attacked it and completely destroyed it. In today's date also, submarines are the most difficult to detect. All the other military vehicles are quite easy to detect by modern GPS system and many other methods with quite an accuracy. There are methods for detecting submarines, but all are quite clumsy and not completely reliable.
We will discuss those methods now. Broadly speaking, the sensors used can be classified as acoustic or electromagnetic, and active or passive. Acoustic sensors look for sound pressure waves under the water, while electromagnetic senses identify various parts of the electromagnetic spectrum. As for active senses, they emit a shaped pulse of energy or a ping and collect any returning signal that is reflected off part of the submarine. Passive senses, meanwhile, listen to and collect any noise in the environment, which hopefully includes an emission from the target. The most familiar sensor is radar, which stands for radio detection and ranging. Radars send out a pulse of radio frequency and then wait for a return pulse as it bounces off a target. Knowing the speed of light and the time it takes to get a return, you can calculate the distance to the target.
The two most common passive sensors for the electromagnetic spectrum are electronic support measures (ESM) and optical devices. Optical sensors are possibly the oldest method of detecting submarines, dating back to the vulnerable but still useful. Modern variants are sophisticated electro-optical digital devices that extend beyond the visual spectrum and into the infrared and include a high power zoom function to see at extended ranges. Meanwhile, ESM listens to a broad range of radio frequencies, hoping to pick up the submarine's emissions, such as its radar.
Both of these sensor types can however only be used when the submarine is at the surface or lie at periscope depth, the depth at which periscope and mass-mounted sensor can break the surface. Given that this is when a submarine is at its most vulnerable, it's not surprising that submarine commanders prefer to keep their vessel fully underwater, leaving only the acoustic domain as the main detection medium for a MPA crew to exploit during their hunt.
There is, however, one exception: the magnetic anomaly detector. This is an extremely sensitive magnet usually housed in a pod at the back of an aircraft to isolate it from electromagnetic noise generated by the aircraft. This sensor measures Earth's magnetic field and senses any anomalies, alerting the crew to the potential presence of a submarine or other large metal object under the water. There are several difficulties with finding submarines using sound. The biggest of this difficulty is other sources of sound in water. The ocean is a very noisy place and it is getting noisier all the time.
Another problem is that underwater sound doesn't travel in a straight line. Much like light refracting through lenses, sound waves are subjected to Snell's law of refraction and bend in fluid because of the changes to the speed of sound in the propagation medium. In the case of ocean, the principal factors affecting the speed of sound in water are temperature, depth, salinity, and amount of suspended particulate.
If you know the temperature as a function of depth, you can now fairly accurately calculate the sound speed.
Another factor which disturbs is the aquatic life like whales. Submarines' shape are keep quite similar, so a similar image will be formed when radar is used.
There are many sea species which can create their own electricity. This can affect the Earth's magnetic field at that place. The magnetic anomaly detector for submarine cannot work efficiently at that time.